exactly is gravity? Well, basically it's a force that pulls two objects toward each other. Anything with mass has gravitational pull, and the more massive an object is, the more gravitational pull it has. Earth's gravity is what pulls everything towards the ground and what causes objects to fall when you throw them up. Now let's get to some history. No one knows for sure, but the legend is that a guy named Sir Isaac Newton, who was a genius mathematician and physicist, discovered gravity when he was sitting outside one day and saw an apple fall from a tree. It then made him think about the forces of nature. This idea was shaped into what is now called the universal law of gravitation.
What is the law of universal gravitation, you may ask? Basically, it's a law that states any two bodies in the universe attract each other with a force that's inversely proportional to the square distance between them and directly proportional to the product of their masses, and can be implemented with this nice equation. F equals g times m1 times m2 divided by r squared. Determine the force of gravitational attraction between the Earth and a 70-kilogram student if the student is in an airplane at 40,000 feet above Earth's surface. This would place the student a distance of 6.39 times 10 to the 6 meters from Earth's center. Now for the sample problem, we were able to substitute the given values of g, m1, m2, and r into the universal gravitation equation to solve for F-grav. Now that we have our values, plug it into the calculator and you'll get F-grav to be 686 newtons. What about space? Yes, of course there's gravity in space. Gravity is what gives shape to the orbit of the planets, the solar system, and even as big as the galaxies. Other planets have gravity as well. Depending on their mass, density, and shape, each planet has a different gravitational force, which is why your weight will differentiate on other planets. All of us are on Earth, though, and most of us will stay here forever, so let's just focus on what's going on here. Gravity is what holds Earth together, and it even keeps our atmosphere wrapped around it. Here on Earth, we are all pretty strongly pulled toward the ground. I mean, I personally haven't seen anyone float away yet, but anyway. On Earth, the force of gravity holding you and I down is 9.8 meters per second squared. Oddly enough, the force of gravity is slightly stronger near the poles than near the equator. So technically, if you went to the equator and weighed yourself, you'd weigh less than if you weighed yourself in the North or South Pole, for example, because of the centripetal force. It's not significant enough to change anything too much, and the number can still be rounded to simply 9.8. I know you're wondering the big question. What in the world would happen if we didn't have gravity pulling us down? Although this is impossible because Earth has mass, and it will never lose its mass. If gravity were somehow shut off, everything would just start floating away from Earth in a straight line faster and faster, and their distance increased. Even the atmosphere itself would float away, and eventually Earth would break apart because gravity is what holds it all together.
Ah, gravity, thou art a heartless